Kristóf Hörömpöly, the speaker today, is currently a VP of risk management at ValidMind, which is a startup here in Boston. Prior to his current role, he was leading a responsible AI team at JP Morgan and PayPal. Kristóf has a bachelor in math and master's in applied math from the Budapest University of Technology and Economics. And without further ado, Kristóf.
What I want to talk to you all about today is something that's been in the news quite a bit recently, in the last 2 years or so, which is, of course, the advances that we're making in AI and how we're going to be approaching the changes that are coming, so to say. So the first thing I want to talk about is the title. So leading the leap, safely transitioning to GenAI innovations. It sounds maybe a little cliche, a little odd, maybe a little clever. The point is it was generated by AI. And I promise that's the only thing that was generated by AI in the presentation. But I think it reflects a little bit where AI stands right now, which is that it does a pretty good job of doing a lot of things to a certain level. However, I would say that if I would have asked a human who is good at making titles to make a title for me, they probably would have come up with something a little better, right? So it has a lot of general capabilities that it is able to execute to a certain level, but I would say that level isn't generally at the level of an expert in that space. Now, what this means to some extent is that we're at an inflection point in terms of where AI is going to take us. So if we think about how AI has developed in the last 20 or so years, there's been a very massive leap in the last 2 years in terms of capability. And I think what we are seeing, and this is my personal opinion, is a prototype for general intelligence. Now, of course, that is debatable, and I would love to debate that with all of you. But I think what we're starting to see is a glimpse of what AI can bring and how strong AI can be if we keep going down this path. But of course, we are still seeing the challenges and the difficulties and the potential risks that are going to be arising on that path. Now, in terms of how we manage these risks and how we govern AI at this point, I would say the leap in the last 2 years is much more significant than moving from traditional statistical models to machine learning models. So traditional statistical models to machine learning models, generally the issues that we were facing or the risks that we were dealing with were very similar. Now with GenAI, with large language models, we are starting to see these risks emerge in a different way and potentially new ones emerge, which I'll talk about. Again, that's debatable. It's a good conversation. We can get into that. So some of the things I want to talk about today are what we're seeing in the headlines and what that means ultimately, how the regulatory landscape is changing, and I won't bore you guys with that a lot. But it's worth knowing the major points across the globe as we move forward in this. I'd like to talk about how, at least from what I saw in my experience, how GenAI is actually different from traditional or classical AI. What are the actual risks that we are seeing in practice? How we would go about GenAI deployment. And this is, I would say nobody knows this, right? This is something that everyone's trying to figure out. But I basically was able to see that process from zero to production at JP Morgan. So they implemented it one way. There are, of course, other ways to do it, but it's going to be a lot of work for anyone who wants to do this in a conservative and somewhat risk-averse manner. Then thinking about the assessment of risks once you decide to deploy a GenAI solution. It's of course part of the deployment, but I just want to drill down a little bit more on that. The actual challenges you'll be running into, and as well as use cases that you probably should avoid, and then the opportunities that you should jump on because it's low-hanging fruit, and it can definitely improve productivity and your overall output at your organization. I think I'm estimating that it's going to take about 40 minutes for me to get through this, 45 minutes, but I have no idea how long it's actually going to take. So please feel free to interrupt me anytime. I want to make this a discussion, and at the end, we'll have plenty of time for questions. So I'm sure you've seen at least one, maybe all of these headlines in the news. Gen AI sometimes does do things that it shouldn't be doing, or people use it for things that they shouldn't be using them for, right? And so there were cases where a lawyer was citing cases that didn't exist because ChatGPT provided those cases to them. I think we all know about what Google's Gemini created recently in terms of photos of World War II pictures. There's other stuff. Canada Airlines had an issue with their chatbot recently. Sports Illustrated is making up writers. So, all of these are in the news. So clearly there are risks and there are problems. But I also want to talk a little bit about what we don't see in the news. And to me, it's actually surprising how little we see in the news, which to me means that, you have at this point billions of people using these tools. And these are kind of the headlines that you're seeing. And you can probably count them on two hands because there aren't that many blunders in Gen AI. So a lot of the time, it's actually working very well. So I think that should be an indication of the direction that we're going in. And we also have to realize that the best way, because they have such broad capabilities, the best way to test Gen AI is ultimately to release it in a safe manner to the public and have testing at scale, which means allow billions of people to try to break it, right? And that's exactly what happens in some of these cases. And that's how you learn, and that's how you iterate, and that's how you make the AI ultimately better. But of course, these things happen, and so regulation is coming. And the EU AI Act was just recently passed, though. That's probably one of the more comprehensive ones that we're seeing. It's going to be coming into effect in the next couple of years. It's going to probably take a lot of resources for a lot of companies to comply with that. So I think we have yet to see how it's going to affect innovation and whether Europe can stay ahead of, keep up with the curve in terms of AI because of the AI Act. But they were ultimately the first ones to have this comprehensive AI regulation in place. In the US, most specific to us, there is nothing that is federally binding, of course. We have a few things that have come out and some things missing there, but basically the NIST risk management framework in AI is something that, at least in financial services, is what people are looking to in terms of what regulation might bring. And the reason for that is because NIST also released something in the security space, which then became law. And so, we're expecting that to be the direction that we're moving in. Then there's an AI Bill of Rights, which was published recently, and there was an executive order by Biden also not so long ago. All of these are dealing with guidelines, but again, guidelines around how AI should be developed and deployed responsibly. On the local level, we actually see a lot happening, right? So if there isn't federal regulation, that means that we're going to be seeing the states step up and at least for certain use cases start to regulate. And so, for example, in New York, we have some regulation in place in terms of using AI for hiring and HR purposes. California is also progressive, and I think even Massachusetts has some stuff coming already. But basically, it's a patchwork of state level laws that you will have to navigate if you operate in different states as an organization. There is the AI and Data Act in Canada, which is also going to be very relevant. And honestly, I could have overwhelmed you with a bunch of stuff on this slide. Yes.
Can you measure where your company operates or where your people work or where they use your product? So, for example,
it depends on the jurisdiction. If it's ultimately your product that matters, but your data, for example, is very important. Where your data resides, where you use the data from, how you train it. And that, for example, also is GDPR related in the EU. In terms of how it affects employees, for example, it could also apply, in which case it also matters where your actual workers are. So again, different parts of the regulation apply to different parts of your business. So you will kind of have to navigate that patchwork. It's becoming more and more difficult. And ultimately that is probably one of the biggest concerns of large organizations, that they have to navigate globally disjoint regulations right now. And this is going to be more and more demanding and more difficult ultimately. So ideally, there would be some sort of consensus on a global scale in terms of what needs to happen to regulate AI, but we are incredibly far from that. And I don't know if we can have that level of cooperation to actually have that. So we have yet to see what is coming. But also, so China is an example where you already have a lot of rules that apply to AI. So if you're operating in China, you already have to navigate them also. And there's a million more that are popping up all over the world, but not super exciting. So I'll move on from here. So a few things that I want to point out about what I mentioned in terms of how Gen AI is different from classical AI. The first one is the data. So if you think about any sort of statistical model or any sort of machine learning algorithm that you heard about in the past, it would be targeted to a specific use case, and it would be using data related to that use case. So you would basically have experts in the field who could review that data, collect data, clean that data. They could own and be responsible for that data. That also meant that the data was quite limited because it was for a specific use case. So you could say that it never got that big. Now with Gen AI, ultimately the more data, the better. And it almost doesn't matter where it's coming from, right? You need some sort of quality check, but you're basically just hoarding data from everywhere. And it's much more difficult to actually have a process or people in place who can review that data and actually confirm the quality, the validity, the relevance of that data. And of course you need this because you are ultimately creating something that is converging to general intelligence. So the more data you have and the more topics you have, the better you're going to be on. The use, again, this already touched on that briefly, but traditional AI was always constrained to a specific use, right? So you knew exactly what the model was trying to get to in terms of results. With Gen AI, you really don't have any constraints. You can come up with any sort of use case for a robust Gen AI model. Development of these models. So at most large organizations, you would have teams developing machine learning solutions, statistical solutions for the business problems that you had. For Gen AI, almost all of your models will be coming externally, either from a vendor or from an open source, because very few organizations ultimately have the resources to train one of these models and to maintain one of these models and to update one of these models. This, of course, brings a host of risks, especially when you're talking with proprietary model training in terms of transparency, and we'll get to that in a second. But before that, the other very important shift in perspective is how you actually govern the life cycle of these models. So in classical machine learning, you were able to focus your review and governance processes around the model itself. Here, it is incredibly difficult with GenAI to do the same because you don't have access to those models. So you have to start focusing on the use cases. And when you start focusing on the use cases, you no longer have model risk or model review teams that involved because they don't have access to the information that they ultimately need to do their job. And so you start to bring in compliance professionals, legal professionals. Ultimately, a much larger part of your organization needs to be part of the use case evaluation compared to what it used to be before. And then kind of a something interesting that I have very strong opinions on is the idea of explainability with machine learning. It kind of used to be an expectation with traditional machine learning. You always had ways to list the feature importances. Even with neural networks, you would come up with some sort of model to approximate how the underlying neural network was actually working. And you were able to list the top features that were contributing to your decision. For example, at a minimum, right? With GenAI, we are very far from any sort of meaningful explainability of what is actually happening. And the issue is that even if we are making progress in terms of how to model that, the scale, the complexity, and the size of these models is so big that whatever we come up with that we can comprehend will be a huge simplification of what's actually going on in the background. And so where is the industry shifting? I think the industry is shifting towards less expectation of explainability because we are accepting that we're not going to be able to understand what these larger models are doing, but we still want to be able to use them, right? So nobody's going to say, well, this is doing all my work and it's doing my work really well, but I don't care because I don't know how it's doing it, so I don't want it. Ultimately, we're probably going to have to transition into a model where it's going to be an empirical evaluation of inputs and outputs. And as long as we can map inputs to outputs in a meaningful way and they make sense and they're accurate, we're going to care less and less about what's happening in the middle. But again, it's something up for debate. It's just something that I'm sort of
Maybe it will become a black box.
It already is, right? I don't think there's anyone right now who understands what's actually happening. But it's, it can go two ways. It can become more and more of a black box, or we can start to untangle a little bit what's actually going on. And I think research is going in both directions, so we can see that
it's a black box. You don't have any expectations. You are agnostic what's inside.
Yes. But I think what we used to call a black box, like a traditional deep learning or neural network architecture, is much less of a black box than what we have with transformers. So there are levels of black boxness, so to say, and we're reaching a black hole, yeah. Yes, exactly.
And isn't it a big risk using something that you don't understand how it works?
Absolutely, but here's my analogy. Let's say we develop an AI that does diagnoses for us on whatever we have, right? Let's say we have a number of symptoms and it's able to diagnose us. And let's say empirically we've shown that those diagnoses are correct 95% of the time. Well, let's say the average doctor is correct 75% of the time. So would you rather have 75% with an explanation by a human? Or would you rather have the 95% and no explanation?
And how about the medicine? Would you take something that cures the disease, but you don't understand how it works? Or
would you? And that's the question, because I think the population is currently split on this, right? And the more you converge to a level of accuracy, the more like, or the bigger the population will be that will accept a lack of explainability because of the empirical results of what the AI can do. That makes sense. Yes, your troubleshooting options are limited. Yes. Yes.
But we don't understand how it developed itself. Control.
Excellent question. And for now, yes. Well, we're ultimately developing it, and we have the option of a human in the loop. So it's not in control of what it does, although we have some influence. There are parameters which we can meaningfully control to affect the behavior, even though we don't necessarily understand what's happening. But of course, at this point, we're not afraid of the AI taking on its own life, some sort of form of life, because we still have agency and we still have control over whether we run it or not, whether we accept the results or not. For how long? I cannot tell you that. I don't know. I actually don't know, and I think it's something that we need to consider. That there is this philosophical question: should there be a kill switch for the AI, and what does a kill switch ultimately mean for an AI? And I think when you have the analogy is algorithmic trading, right? You have a system that does trading for you automatically, and suddenly you start to lose a lot of money, then you can shut it down and it stops. In a similar way, if you have AI that does a specific task, you'll be able to shut it down because you just stop it. But when you want the kill switch because AI is taking over, it's probably going to be too late because the AI will be too sophisticated for us to understand. The AI will have its own resources to reproduce or to maintain itself. And then the kill switch will not really be meaningful. But again, we're not there yet, but we have to think about what a kill switch means. And if we can reasonably expect that a kill switch will solve our problems once we actually have those problems. And I think the answer is no. Then it's going to be too late. We have to think about alignment before we need the key switch. Yes.
How is it that the AI is able to come up with the solution but not explain how it got there? Or is that just, your doctor example, wouldn't that be interesting for the doctors to understand the analysis that the AI used to learn and further kind of close the loop?
Yeah, so it's interesting because it is a language model, right? So it will use language to explain its own process. But again, it's either going to be an oversimplification of what actually happened so that you understand, or it's going to be too involved, too complex, and too much for humans to really interpret. So I think the biggest issue is just the scale of what needs to be explained. We as humans are not going to be able to meaningfully understand that.
So do you think that means, in your opinion, that the potential intelligence of GenAI far exceeds human capability? I don't think it currently exceeds human capability. What I think is it is approaching it, right? I think we have this idea that our mind is so special, but if we compare it to what AI is doing, it's actually doing something quite similar, right? We learn from patterns. We learn from the patterns around us, and then we apply those patterns to similar situations. The question is, how far out of the box can we think when we apply those patterns, right? And most people, I would say, cannot think that far out of the box. And the AI can also think it has a convex subset of what it's seen, and within that, it can operate incredibly well, right? And very few humans actually go outside of that subset in terms of creativity. It is very rare to have a genius who doesn't put things together from the things that they have seen, right? So I think it is approaching that. It can memorize a lot of patterns and it can retain those patterns, unlike us, right? We forget things. So So yes, the reasoning capabilities are not there yet, but I do think we are converging to that. And at one point, they will surpass ours. Yes.
Sorry, it's at least 2 more years.
Yes, I agree with that. Yes.
Do you expect that like explainable models from MLs, just random for to like back up GenAI results, help us understand them, verify them?
So fundamentally, I don't think you can use traditional machine learning to model language models, right? It is a very different architecture. It's very difficult to model things that happen in a language model with traditional machine learning techniques. So I haven't seen much success in that space. Very good questions. Thank you, guys. So then, in the now, in practical terms, what are the actual risks that we are seeing with GenAI? And some of these risks you will recognize from traditional models and machine learning. Of course, one of them is the data risk, right? How do we deal with the data that we get out of it and the data that we put in there? And of course, there's a lot of privacy and confidentiality risk depending on what it's trained on, depending on if the provider of the GenAI is using that data to then retrain. You have the risk of data being out of date, right? And what that means in terms of answers that are inaccurate. Data poisoning, which is more complex with large models, but it can still happen. And then on the model risk side specifically, so explainability, we talked about quite a bit. And then one of the biggest ones, of course, is hallucinations. And hallucinations are the equivalent of a wrong answer from traditional models, basically, right? The only difference is that these hallucinations can really mislead us because they can be incredibly convincing. It can, it can come up with really wild things about any sort of topic if it needs to. And actually, from our evaluations at least at JP Morgan, what I found was hallucinations happen much more frequently when you ask about something that doesn't have an answer. And that makes a lot of sense, right? So if it already has some sort of answer in its training set about the topic that you asked about, it will give you the right answer most of the time. But if you ask about something that it doesn't know, then it will do some pattern recognition and start to create a story that sounds about right. So you will see hallucinations much more frequently when there is no answer. Another one is legal risk. And here it's, this is to be seen. This is kind of a gray area because we don't know where the IP rights stand in terms of the generated content, right? They're gonna have to figure out what was used to train these models. And then once you create content, who owns that content, who has the rights to that content. All of that is actually legally not clear at this point, so we have yet to see where that will go. Of course, there's a lot of reputational risk, and this comes from a number of things. The headlines that you guys saw, so there's bias, there's toxicity, all of these things. Without the filters and the guardrails, the GenAI reflects who we are as a society today, right? And it's sometimes it's beautiful, but sometimes it's ugly, and it's going to come out full force if there is no filtering on the content. But of course, then you have the question of what it means to filter content, and there are a lot of ethical concerns around that also, because some people will decide at a company that, oh, this content is offensive or this content is politically incorrect or whatever, but it may actually be sidelining another community. So we can get into that whole discussion. But on top of that, every single time you add a filter onto the model, a content filter, the performance of the model gets worse, right? So it ultimately affects the natural functioning of the model, the way that it naturally trained itself. So you're going to be affecting performance in other areas also. And there were, I mean, we had this also where Microsoft put in a content filter, and then for some stock tickers, it was not allowing us to run the model because it thought that it was sexual content. And it was just 4-letter acronyms that we were putting in, not those ones. And then, so these first of all risks, you know, you could put these into categories of risks that we've already dealt with other models. They're generally augmented, they're generally slightly different. But then the question is, do we have actual other risks that we can identify? And most of the time, I would say no at this point. But I think an interesting idea comes into play here, which is emergence. And if just for a quick definition, emergence is basically when the AI starts to exhibit behavior that it was not trained to explicitly do. And I can't say that I've seen this a lot or even a little. However, there are definitely glimpses of what could happen. And one example was we developed a bot internally, which was helping us to code. And one of the developers asked it to write a code in a certain manner. And the response of the AI was, well, I could do that, but here's actually a better way to do it. So I'm going to do it this way for you. And you could argue that it's basically just human nature that was coming out, which is human nature. You know, we like to correct and we like to know better and things like that. But also ultimately, we asked the AI to do something that we wanted in a certain manner, and it decided to not do it because it knew better, right? So there are potentially risks emerging that we just need to be aware of and keep tracking. Yes.
Maybe you think this is included in those other risks, but do you think there's a risk of like bad actors or people intentionally creating models or manipulating models to give the output that they're looking for?
Absolutely. And of course, there is a huge potential of abuse of this technology, right? So in terms of even just thinking about deep fakes, thinking about fraud, and that's also why ultimately it's very difficult to slow development of this technology, because at this point, the only thing that can recognize that sort of fraud and deep fakes is AI, right? So if we decide that, okay, in the West, we're just going to halt AI for a little bit until we figure out what we can do, there will be bad actors who will continue to develop it. They will get ahead with sophisticated malicious technology, which we will not be able to intercept, so to say. So we need AI to combat AI at this point. Absolutely, yes.
He's saying that we need the bomb. Yeah, it's pretty similar to the Manhattan Fly, actually.
Yes, I'm not
doing someone with it.
And unfortunately, it's absolutely the case. Yes, yes.
I have another idea for the risk that was not mentioned, and it's freedom. Here's what I mean.
Say that again. It's what?
It's about freedom, and this might sound as a sort of conspiracy theory at this point, but like, what do we know, right? It's going to be a couple of years ahead. We don't know where we're headed, and I have an honest fear that so much content on the internet is going to be generated. I mean, it might already be. I don't know if there are estimates out there that eventually you won't be able to trust anything out there, like video content, anything. It's very quickly going to be showing up in political campaigns, compromise that the Russians call it, right? And then once there's going to be a point when a politician is going to say that this is harmful and like we need to control the content, and they are going to try and introduce a sort of internet license, the kind that I think was already attempted in Australia. Back then, I think they wanted it to be about age, like age restricting content. You need a license. Children shouldn't be on the internet. I think there's a very clear path to this. And at this point, it might sound ridiculous, like, well, who would attempt that? But we know. Do you think this is realistic?
So these risks, I'll go back to this for a sec. So this is a very abstract area here, and I have some other ideas about it. So these are risks that we're actually seeing now, right? It's in an organization like a bank, you're going to be running into these risks. This and what you mentioned, I think, are absolutely possible, right? And there are massive societal implications of AI becoming very strong. And yours is a great example where we might lose our freedoms because it gets so out of control. But if you just think about the fact that if AI starts to get better than humans at the work that humans do, where does our purpose go, right? So much of our society identifies itself with the work that they do, right? It's going to be a mental health crisis at a very different level if people realize that their work is meaningless compared to a machine that can do it much faster, much better, right? And it is coming, right? And we as a society need to start preparing for the implications of that. And universal basic income is not going to do it because people are not going to be happy sitting at home doing nothing, right? So there needs to be a new sense of purpose as well. So there are, I think in the next 5 to 10 years, if things continue, and I expect them to continue, then we're going to have to figure out a lot of societal issues. But again, steering back to the practical a little bit, what you can actually do today. If you're at an organization and you want to use GenAI and deploy GenAI, what are some of the things that you can actually do? First of all, keep track of what you're using it for and how you're using it for. This sounds simple, but it's actually not. And it's becoming very, very simple to implement a GenAI solution using an API. So just making sure that you have a list of foundational models that you're using and use cases that use those foundational models and have that properly logged is going to be incredibly, incredibly important. Think about the data use. Every single time that you use it, think about what sort of data you want to allow into that application and what sort of safeguards and security features do you have so that data doesn't get into the wrong hands or doesn't get sent back to OpenAI for whatever reason and then used in the training set. This is an incredibly complex and long problem at the enterprise scale if you really want to keep your data secure.
So what are the solutions now, I guess, having this was your previous job and your current job? Is it that, because people, even if you don't provide the service at enterprise level, then people are still going to download ChatGPT or make an account and feed the information in.
And that's exactly the dilemma that you're going to be facing,
Yeah.
that you're damned if you do, you're damned if you don't, because if you don't provide an alternative internally, then everybody will go to their private devices and start to generate content, which is the most unsafe ultimately, right? But internally, if you actually want to protect confidential data, you need to completely segregate your environment. And that is incredibly costly. If you're going to have that contract, let's say with Microsoft and with OpenAI, where you're completely walling off your data, you have your own instance running of the model, so to say, and there is simply no interaction between the external ChatGPT and the internal ChatGPT. But
so I know that Harvard and maybe Harvard Medical School have some of these agreements because of the sort of data that they put in. Maybe you can't talk exactly about the company you were at, but let's say generally large financial institutions, like are they just rushing to make the deal with OpenAI? Or, because it's very hard to make this internally in a short timeline, or even a medium timeline.
As in like train your own model.
Train your own model.
Impossible,
yeah,
right?
Exactly.
Impossible. And the thing is, the data that say banks or hospitals have is also very specific.
Yeah.
You need a general language model first to be then able to build or retrain or fine tune ultimately with your own data. So it makes sense. So the whole reasoning capability will come from the underlying language model. And then you can add on the data. But then, yes, you then need some sort of contract or some sort of access to that underlying model.
Okay.
If you train your own model from scratch, it's not going to be nearly as efficient in producing language as these models. But yeah, so when you get into development, yes, sorry.
I mean, that is the future, right? That is the key. That is the future that we are going to be taking LLMs and training our corporate data in those transformers. And they will be having proprietary data that they're transforming.
Yes, so and there's a few ways to accomplish this, right? And the question is what path each organization will take. But the most sophisticated one is when you fine-tune the model to incorporate your own data, right? But that requires a lot of work. It usually requires peeling down the architecture a little bit, so to say, of the neural network.
Where we're all headed as corporations?
Well, there are simpler solutions like retrieval augmented generation or just linking vector databases. You can actually link your own data in less computationally intensive and resource intensive manners. And it's still going to work ultimately. You think of it this way: you link a database that the large language model has access to, rather than retraining the large language model to think in the spirit of the database, right? That's the difference, and it works quite well actually. If you do that. Through RAG, for example.
RAG instead of just.
Yes, exactly, and that's much less resource intensive. Yeah, so in terms of, so the development is again going to be a very different type of development compared to traditional AI. You're going to need to be experimenting with the models, but also with prompts, with settings. There are all these different aspects which now come into play. Prompting is an art in and of itself, right? And actually I think one of the best ways to prompt is to ask the model to prompt itself, right? And then you can start to go back in time and exit to prompt itself. Anyways, there are many ways to go about this. It's very good at prompting itself. Testing, benchmarking, of course, you have different models, different types of prompting. It's a lot of work, right? If you're going to do this at the foundational model level, it's almost impossible. So you're going to need to get into the use cases. Then the risk assessment, right? This I touched upon a little bit, but how do you actually evaluate the risk and how do you approve the use case or the model? And again, while traditionally it was just a quantitative team that went in there to check whether the model is sound and what data was being used and all of that, now you start to bring in the legal team, the compliance team, the controls teams, because the model risk team can do so little of their job ultimately. Number 5, I think, is maybe one of the most important ultimately, which is you need to train your users on what they're dealing with and how to use it. If you had a quantitative model at your firm, it was generally being used by very quantitative people. Now your use cases are generally in the hands of business people, of HR, of various employees that you don't necessarily know what their understanding of GenAI is and how much they're going to over-rely on that application. So you really have to focus on the disclosures, the risks, the education of those employees. And this is, again, very resource intensive if you have a large organization. And then once you deploy, how do you monitor? And here, again, you can put in automated guardrails. I don't think they generally work well. But creating a very fluid feedback mechanism for your employees to report on problems is one of the best ways after you have the education and after they know what they should and should not be doing with GenAI. The rest I think I'll be able to wrap up fairly quickly. When you start to get into risk assessment, what questions do you ultimately ask when you decide how risky your AI is? And these are the ones that I would put on the top of the list. I'm sure there's others. First one, is it client facing, right? So if you think about what it means for your clients to interact with your application versus your employees, there's a massive difference. you can educate your employees and you can tell them what they can and cannot do. While your clients will almost certainly try to break it or will certainly try to provoke something that it shouldn't give. And then you're going to be in trouble. Then you're going to be on the headlines of the New York Times, which you ultimately want to avoid. Does the application have any sort of regulatory implications? Of course, just super sensitive. So just don't go there unless I don't know. I mean, just don't go there. Automated decisioning, right? If you take the human out of the loop, and not just the human, the expert out of the loop, and it creates automated decisions, of course, you're at a much higher level of risk. And then finally, what is it actually doing? What is the implication of the decision? Is it affecting the livelihood of somebody? Is it potentially affecting the safety of somebody? If you answer yes to any of those questions, then obviously you should be incredibly careful with implementing a solution. These I think we've already mainly touched on. I maybe just want to just reiterate a couple of things. First, we're testing and ongoing monitoring. The difficulty is that you cannot put together a test suite that will test the foundational model. It's just capable of doing too many things that you're never going to be able to check for everything. So you're going to have your business owners who develop the specific use case to create their own suite of tests, which test that specific use case. And right now, I think it's very easy to implement a solution. It's becoming much more difficult to test the solution. So until now, we've had teams develop AI models over the course of months and then test them. Now you can implement it incredibly quickly, but you cannot ignore the testing and the monitoring part, which is still going to take a lot of time, and in some cases actually more time. What does human oversight really mean? It doesn't just mean human oversight. It means you need somebody who understands the topic to be able to step in and to be able to review the content that is generated or that is out there. And then finally, who's responsible, right? And I think a great example is the Canada Air situation, where I think Canada Air was trying to argue that the AI is its own legal entity or something, so Canada Air can't do anything about it, which of course didn't work out. I mean, obviously they are responsible for it. So yes.
I have a question about the testing. You mentioned you can use it to prompt itself. Are there any ways you can trust it to test itself?
You can't trust it to test itself. You can ask it to test itself, and it usually creates good things, but you will still have to in some way validate that
two different GenAIs kind of test each other.
And that's actually yes. And also in terms of hallucination control, one of the best things that you can do is you rerun the model and do a compare, right? It's very unlikely for the model to hallucinate the same thing twice. Or you can even have it generate content, and then you go line by line and check back against the original content to check whether it's included. That again is a great way to get rid of hallucination. So actually having Gen AIs checking themselves or checking each other is probably going to be the way to best mitigate hallucinations. Yeah. Okay, and where are we? So what do you not want to use it for now? And you probably can't. So consumer lending, anything that has to do with fair lending right now is just a big no-go because it requires explainability. So you're not going to be thinking about that. In HR, it's incredibly sensitive, right? If you're thinking of using it when you're making hiring decisions or anything like that, you again need explainability. So you probably have to forget it for now. You can use it as a tool maybe in some instances, but generally no. Medicine, insurance, you're talking about the safety of patients, right? So again, incredibly careful. However, there are a number of areas where you can already use it very safely. And I think one of the first where you can save an incredible amount of time is software development. And the reason I would say that is because whenever you put code into production, it has to go through a rigorous review and testing, right? So you're ultimately just creating a first version of the code that your developers are going to be tweaking and reviewing, but that they can submit. But creating that first version can save a lot of time for software development. Second one is summarization and data retrieval, right? You can have massive docs that you have to review. Let's say you're a lawyer, or I don't know, you're working in some area where you have to review docs. It can actually get you a very good summarization, and it can also do very good Q&A. And you can, of course, always check back against the original content, but it will give you a very good starting outline of what you're dealing with. And also just creating your first drafts of everything, right? If you take ownership and responsibility of that work and don't just pass it on as is, then it can create incredibly good first drafts for your reports, for your white papers, or whatever you need. And I went pretty much over.
Image, video, and music, like, is that all?
So then the reason is because I am incredibly biased, because I was in banking and we don't do any of that.
I mean, it's amazing. I saw Adobe today.
Yes.
It's
Yes.
Image,
absolutely. And if you think about marketing,
$100 million facility, because now you can just generate.
exactly. Yes, it's yes. Marketing campaigns, all of that, you can get done in a fraction of the time compared to before. Yes, and money. And then a lot of people will be out of work because of that.
Well, it's like any team. You know, those people that
yes.
ATM,
they need to reskill.
They got
yes.
different jobs.
Yes. yes. While there are still jobs available. Yes, exactly.
My grandmother said that to me. She saw an ATM. She's like, "Oh my God, what's going to happen to these people?" I'm like, "Don't worry."
Yes. Yes.
Yeah, they're in supermarkets with cash.
Yes, I mean, I think the question is when you start to have massive replacement in a lot of industries, right? I think that's what we haven't seen yet. I mean, yes, you can compare it to the Industrial Revolution in a way, and people figured that out. But the problem is that you're seeing white collar professionals primarily being automated of their jobs based on seniority level, right? You start with the analyst because it's starting to do things better than the fresh college grad or the analyst. You still have those senior experts who can do better, but slowly that's going to trickle up the chain. And you're going to see that in more and more industries. And then what happens? And I don't know if we have.
I think it's true. You have high school students in this room who are going to be part of that.
Exactly. They're going to have to figure it out. They're going to have to figure it out for us. Yes, exactly. And so that was it, actually. Thank you. So the rest is time for questions. Yes.
Okay, so not exactly about the lecture, but
sure.
You said that you worked for a startup. What does the startup do?
Yeah, so I just joined the startup, and basically it creates a AI lifecycle governance platform. So basically it follows the life cycle of the AI and involves all the stakeholders in how they need to develop, test, validate, and then monitor. And it also automates the documentation for the models and for the AI. So you can link tests, it will run the tests for you, and it will create the full documentation of your models and of your AI. So quite relevant. Yes.
Somewhere I read that we are in a honeymoon period, that money is flowing into this industry as is now no tomorrow. So when you go and create jumping elephant that costs about $5–10, but of course you're not paying for it because somebody else is paying for it. How long will this honeymoon last, and what's the economy of AI generation? I heard of creating these models is now $1 billion, and it's forecasted to be $5–10 billion of the next generation model. No one can create it otherwise. And I heard United Arab Emirates is creating one.
They still have enough money.
Only companies with that kind, or nation states with that kind of monies can create one. now we are enjoying it. We are happy. We can go to ChatGPT and ask our stupid questions. Those are not cheap. Those are not free.
Absolutely, and I also like to recommend people that this is not a Google search, right? You're using a lot of water. You're wasting a lot of resources every time you do a request, and that's absolutely true. I think these models will continue to be in the hands of the richest companies ultimately. I mean, until someone comes up with a solution to significantly reduce the resources. But also, I think the honeymoon period may run into other obstacles, which is data, for example. We're running out of data. Most of the useful data has been used to train these. So where do we get the rest of the data from? I mean, if it's synthetic data or if it's generated by these, that's not going to work. That's not useful data. So there will be other roadblocks which will inevitably slow it down. The models are going to be more efficient, and you're also, of course, passing on some of these costs to the consumers. So if you're going to be using OpenAI through the API, you are paying for it, and that will likely be self-sustaining. ChatGPT is free, but if you actually want to use the better version, you have to pay for it. So more and more of these costs will be passed on to the consumer, I would say. We'll see. Yes.
I actually had kind of a question about the data of like, if this really does take on, there's much less human generated data. So is it really going to be innovating beyond its circle that you described, or is there going to be a need?
So right now that doesn't work, right? So right now, if you use AI generated data to further train the AI, it's going to run into issues, and it starts to create weird things, especially over a few iterations. So right now it doesn't work. I can imagine how if you create different architectures ultimately of AI and they generate data for each other, maybe again that could expand the horizon. But right now, AI generated data doesn't really work well to expand that universe, so to say. Yes.
You discussed language models as, maybe I've gotten this wrong, but it sounds like you're kind of speaking of them as synonymous with GenAI models that we have today. It occurs to me that potentially in the future, getting the language right will, do you mean like actual natural language? So
yes, it is natural language, but ultimately what these are called large language models.
Large language models. So is the language in a large language model referring to like a language like Hungarian?
Yes.
Okay, so at some point, won't the language not be the hard part anymore? And like getting the content right? Because if I think about like, hey, I'm trying to solve a math problem, it's language agnostic. Or I'm trying to engineer something, do something. I care about the language. So I guess something you mentioned about like what's hard about solving a problem is like getting such a big language model involved while still partitioning my data. But I'm thinking like the real juice is not so much in whether the thing can speak or understand a prompt, but whether it can get the right answer or a useful answer.
So I think the distinction here is that large language models are actually worse at what traditional ML is best at, which is making calculations, for example, or statistical models, or like the more simpler algorithms are very good at calculating. Large language models are notoriously bad at giving the right answer to the simplest of math problems, and they're actually getting much better, frighteningly good over time. But the like GPT 3.5 was incredibly bad at adding two numbers, or if you asked it to give you a text that was 100 words, it had no idea what that meant. It would just give you whatever, basically. So it does not deal well with numbers because it recognizes patterns in natural language rather than like tabular data or math. Yes.
How come you can code? So I just don't understand.
Well, coding is a language.
Yes, but I think there's a lot of math.
Yes, but ultimately you have syntax and you have it's I would say closer to a language in terms of what you're expressing. than pure math.
So I guess my question is, do you see those problems ever getting split where it's like, okay, we've got the language model as like an interpreter,
yes,
that like lets us speak to a human, and then we have like some other intelligence.
I think what we would love is if you had a reasoning side and a knowledge side, right? And if you could completely separate those, that would be ideal, right? Because then you could segregate knowledge, which you could verify is true, and you would have a complex reasoning mechanism. I mean, right now these are somewhat entangled, right? Which is why it's difficult to do a lot of the explainability and all of that stuff. But if you could separate those two, then we would be golden.
But isn't that already separate? You have an LLM, large language model, and a transformer. They are separate. So the transformer acts on the language. And you can get the so they are separate. They're two separate entities that create a GPT.
I guess what I'm saying is you cannot control the two aspects separately, right? Because what you would want to do is you would want to be able to keep the knowledge base clean and up to date and completely independent of the reasoning aspect of the model. And these currently are intertwined in a way that you cannot separate them, right? And that is causing a lot of the difficulty that we see behind this. Yes.
Not a question and a comment. From a medical perspective, this is definitely being used, at least in my area, which is pathology. We are based in patterns, we're based in images. So now with digitalization of slides and tissues, we're slowly also including all of GenAI just to be able to by pattern recognition path diagnoses that always will be needed, like a doctor needs to review them. So that risk is not going to be transferred to a patient care. So that is just a comment. And the question is, would another of these systems be able to identify what variables are inputting into a, say, result to be able to identify what biases are getting into it?
Say that again.
So it's just basically, if you want to identify whether biases are coming from or present, isn't there another AI that could be able to ask basically what are the variables that you're taking into consideration into this result, so you can identify, okay, this is being biased by this factor. Say,
can you diagnose an AI with another?
With another AI,
yeah.
I see. So basically, since we don't understand the AI, can we use another AI to help us understand the AI?
Kind of, and identify that there's a bias. Yeah.
It's an interesting question, and I think that will probably be the future, where again we're going to have to use AIs to help us with other AIs, and I certainly can. I guess I've never seen that, but I can totally imagine. Right.
It would still need to be oversimplified for us to understand.
Yes, but at least they would be able to point out things that we can then maybe try to dig into the original data and then try to map from data to output and then see if it's true, even though we don't understand what's happening. Yes.
I just don't see if they have the shared bias, then they.
But the question is, if you use a different model, right? If you use a completely different model, which was trained on different data, could it potentially identify bias in another model? And I would say yes, potentially. That's how it is. Yeah. Yeah.
For us students,
yes.
But also, I mean, if you teach AI every day, I can't help just coming back to my original analogy that after we discovered the atomic bomb, there was the hydrogen bomb, which we united with the atomic bomb. So I think there's another way to unfold it.
Certainly. Yes.
Maybe the last question. This is the Hungarian club. So tell me, is the Hungarian model better than the English model? If I ask my question in Hungarian from these language models, will I get more accurate answer?
No. No, it's going to be pretty good, but no, because the training data is much smaller.
And is all the Hungarian available literature and paper being already ingested into the model?
No, I understand books aren't really part of these models, actually. But even if they were, the available literature would be less. So this is very much a numbers game, right? So the more the better at this point in terms of the data. So the language wins, whichever has the most underlying data. And Hungarian is very rich as a language. I understand that, but